Hey everybody, this is Miss Kent with week 3, day 3, number talks. And I hope you were able to watch week 3, day 2, because that had some really great information in it. And today we're going to be working on the similar information. I have an expression on the board, but now I'm going to have an equation. An equation on the board, 2 times 8. If you need to stop the video and work that out, please do. We're using mental math. Most of you just knew 2 times 8 is 16. Because if we double 8, we get 16. I hope nobody had to say 2, 4, 6, 8. That's not very efficient at this point. So we have 2 times 8 is 16. What about 4 times 4? If you need to stop the video now, please do. Well, I already knew that 2 times 8 was 16. And I'm just drawing a number line so I can kind of show you my thinking. So, 8, 16. So because I knew 2 times 8 was 16, I knew 4 times 4 was also 16. 4, 8, 12, 16. What could have made what would have made it easier on me if I didn't know 4 times 4 was related to 2 times 8? I just didn't know that off the top of my head. What is that strategy called? Doubling and halving. I want you to look at these numbers up here. When I halved the 8, I got the 4. When I doubled the 2, I got 4. Okay? So that really helps me. We also know that a 4 is double. So with 4, I double the other number. I get 8. I double 8, I get 16. So essentially when you're doing a double, you're doing halving one side and doubling the other. Okay, let's do another one. Hold on. This little board just doesn't offer enough space for me to do all my work on. 4 times 8. If you need to stop and work this out, please do. Some of you are probably getting really speedy with this, and you're able to answer this quickly. Okay, and most of you answered, or you should have answered 32. I hope you didn't have to count by 4s. 4, 8, 12, 16, 20. That's not very efficient right now. 4 times 8. Now, I'm not really good at counting by 8s, but that would have been more efficient than counting by 4s, right? Like 8, 16, let's see, 16, 8, that would be 24, and then 32. Hope that's right. Yep. See, I even have to think about it. It's taking too long because I don't know how to count by 8s. So that's just not very efficient. Who could think of another equation that would be more efficient? So stop now, and I want you to see, what could I do to this problem to be more efficient? Now, some of you are probably thinking in your head, I'm going to use the distributive property. And inside that 4, there's a 2 and a 2. So I'm thinking 2 times 8 plus 2 times 8. 16 plus 16 is 32. What did I do to that 4? Essentially, I did what? I halved the 4 into 2 2s. If I half the 4, I've got to do what with the 8? Double it. 2 times 16 is 32. So here I would have 16 and 16. Hey, I'm going to do this one more time because I know I can have 2. And if I have 2, I get 1. And if I double 16, I get 32. Hey, that double and halving really helps me because I can keep doing that until I get to my answer, because once I get half the one number, once I half the other number down to 1, the number I'm multiplying it by is going to be the answer. And I know the identity property because that tells me that. Let's look at another problem for today. Today's problem is, or the last problem is, 4 times 6. Stop the video if you need to solve it. Try to think of the strategies that we've been talking about. Well, 4 times 6 is 24. And some of you may have thought over here to use that distributive property again, which is a good strategy. I'm not going to say it's not, but it's not the most efficient strategy when I distribute that 2 and 2, because essentially I'm doing what with the 4? I'm halving it, okay? Not a very efficient strategy at this point would be counting by 4s. 4, 8, 12, 16, 20, 24. That is not a very efficient strategy right now. What else could I have done? What if I half the 6 and double the 4? Let me do that. So that would be 8 times 3. That's still not a friendly problem because I'm probably going to have to count by 3s if I just don't know my facts. That's not good. So let's half the 4 and double the 6. 2 times 12 is 24. But what if I half that 2 and doubled the 12? I really like this strategy because halving and doubling is very beneficial. You can actually work most of the time, now not with every problem, but most of the time you can work it down until you've halved and doubled till you've gotten your answer. Now I want to go back because this was a short number talk, and I want to look at this number line right here that I have, and I want to kind of relate this quickly to fractions on a number line because we have been talking about that. We have been talking about fractions on a number line, and so far all we've talked about is the fractions that occur between 0 and 1. 0 and 1. But this number line is 0 to 24. 0 to 24. There are a lot of fractions here, okay? A lot. This would be 4, between 0 and 4, what would be the halfway point? Would it be half? What's half of 4? 2. 2. That's not even a fraction. I know you're saying it's not a fraction, but if you're thinking about that, the whole is 4, and you want to talk about half of that whole. One part of that fraction would be 2, and another part would be 2, because fractions, remember, are the measurement of the pieces. They're the pieces, okay? A fraction is a piece of a whole. The whole is not always going to be 1. Just want you to think about that. The whole is not always going to be 1. Because the fraction here, I'm just going to write it out, would be 4/4, which would equal 1. well, excuse me, that's incorrect. Let me correct myself. The fraction here would be, I am so sorry, I said that incorrectly. Let's see. I want to say 4. Oh, let me break this down a little bit more for you, because I don't want, let me not confuse you, because this whole thing I know is a little bit confusing, and I'm trying to throw a lot of skills at you at once. So 2 is the halfway point here. What is halfway between 0 and 2? Halfway, is it a half? No, it's 1. Okay, it's 1, not 1/2, but it's 1. What's halfway between 2 and 4? 3. That is a fraction of the area between 0 and 4. Okay, I'm going to draw a bigger model down here so you can kind of see it. This number line starts with 0 and it ends with 4. Okay. There are numbers in between 0 and 4. And what are those numbers? 1, 2, and 3. Come between 0 and 4. Between 0 and 1, there's a half. Between 1 and 2, there's another half. Between 2 and 3, there's another half. Between 3 and 4, there's another half. Look at your ruler. You all should have gotten a paper ruler, and I know it looks a lot different than mine does, but you should have gotten a paper ruler. And if you don't have one, you might have a measuring tape at your house or a yardstick. On this paper ruler, you see there's a 1 and a 2. And in between that 1 and a 2, do you see that mark? That's half. In between the 2 and the 3, do you see that mark? That's half. Halfway between these. Okay? So if I was measuring a piece of ribbon, and my piece of ribbon measured this long, it would be 1 1/2. Okay? On our tape measure, we see the halfway mark, but then we see another little mark, and that would be 1/2 of a half. So 1/2 of a half. What is 1/2 of a half? It's a 1/4. Okay, this is how we get our fractions on a number line, and I know I've probably just really confused you because we just kind of started on this, but everybody's going to get it by the end. See you next time.